Assalamu alaikum. Today I am going to explain retraction. What is retraction? The definition of retraction is here. Let X be a topological space. Means X is any topological space and A is the subset of X or subspace of X. A continuous map R from X to A is said to be retraction of X onto A if R restricted to A domain A from A is identity map, that is the restricted map R to A is equal to ID on A. Means here I am explaining means X is a topological space. X is any topological space. Suppose that R2 minus 0 comma 0 punctured plane or circle or disk B2 or B2 minus punctured punctured disk, and A is a subset of X. A is a subset of X topological space of A is a subset of topological space. Suppose that A is a circle S1. So R is the retraction of X onto A, means R is a map from X topological space to A. If we restrict this map at domain A to A is as like identity map ID map on A from A, means R of A is equal to A for all A belongs to A. If we restrict the domain A to A, so this map is as like identity map of A, means ID map on A from A to A, and the structure of this map is R of A is equal to A for all A belongs to A. So this map is retraction map, means X retraction on A, or we can say that A is retract of X. Let's say, for example, one example of retraction map is here. Here is the example of retraction. The space S1 is here as like A, means A is a subset, is the retract of the punctured disk B2 minus 0 comma 0, and we can say that the termination of origin from disk unit disk, since S1 is equal to X comma Y belongs to R square, and the structure of this circle is X square plus Y square is equal to 1. This is the unit circle and this is the unit disk except origin unit unit closed disk except origin, and the map from X to retraction, we already said that retraction is the map from topological space X to A. So here we have example. Retraction is the map from B2 except 0 comma 0 origin to S1, and the structure of this equation or function R of X comma Y is equal to X divided by X square root of X square plus Y square comma Y divided by X square plus Y square. This is the structure of this map, retraction map. So we can check this. If we apply, this is the desk, puncture desk, unit puncture closed desk. Okay, and R is the map from desk to unit circle. So this map is mapped on the boundary of this disk. We can say that here. So if we substitute some points, so we can check this point. If we let's say this point, and this point is 1 comma 0. If we substitute here, so R of 1 comma 0, we can say that here, and 1 plus 1 square plus 0 square 1, so 1 here. And if we substitute 0 here and 1 square plus 0 square, so 0 here. So this point mapped on this point. If we let's say, if we substitute this point 0 comma 1, if we substitute 0 here, and this term is other than 0, so this is 0. So R of 0 comma 1 is equal to 0. And if we substitute 1 here, and 0 square plus 1 square 1, and 1 the root of 1 is 1, so 1 upon 1 is equal to 1. So 1, the output is of this point is 0 comma 1. So output of this point is here, output of this here. If we substitute this point is minus 1 comma 0. So minus 1 comma 0 substitute if in this function. So minus 1 divided by minus 1 square plus 0 square. So this is 1 and square root of 1 is 1. So minus 1 upon 1 is minus 1. And if we substitute 0 here, 0 divided by minus 1 square plus 0 square 1 square 1, and square root of 1 is 1, and 0 divided by 1 is 0. So if we substitute this point into this function, we will get this point minus 1 comma 0. If we take this point, so how can we realize this point into output of circle here? So we can check 1 upon 2 comma 0. If we substitute 1 upon 2 here, divided by 1 upon 2 square plus 0 square, so square and root is cancel, and 1 upon 2 comma 0. So if we substitute 0 here and divided by 1 upon 2 square plus 0 square, so 1 upon 2 square, but 0 divided by something is 0. So we can see that one upon 2 and square and the cancellation of square and root, so divided by 1 by 2, so 1 by 2 divided by 1 by 2 is equal to 1. So we will get point 1 comma 0. We can see at this point, if we substitute this point in this function, we will get 1 comma 0. 1 comma 0 is the boundary of this disk, means at circle. If we substitute minus 1 comma 0, so we can say here minus 1 and minus 1 square is 1 upon 2 square. So minus 1 upon 2 divided by 1 upon 2 is minus 1. So we will get minus 1. If we substitute this point, so we will get output here. So we can check every point in this disk except origin. So every point lies on the boundary of this means circle, the boundary of circle. So this is the retraction map from punctured disk to circle, and this is a retraction map from punctured plane to circle is the surjective map according to the definition. This is a surjective map. Every point of this lies here. So we will get all the boundary of this disk at output. So this is the subjective map. So this is the example of retraction map. And if we restrict the domain at A, so this map from A to A is identity map of A. A to A means R of A is equal to A, or all A belongs to A. Means if we restrict this domain at S1, so this map from S1 to S1, and this is like ID map on S1 from S1 to S1 and the function is R of S is equal to S, and for all S belongs to S1. Here is the function R of Z. If we restrict the domain at S1, so this type of function is here Z upon Z modulus norm of Z, as we know that norm of Z is equal to 1. This is the unit circle and this is equal to 1. The unit length is 1. So we can see that if we substitute every point from the circle, means here is the domain and this is the codomain, this is S1 and S1. If we substitute this point, we will get this point. If we substitute this point, we will get this point. If we substitute this point, we will get this point. If we substitute any point from input into this function, we will get same point, because this function is divided as like a Z, because modulus of Z, norm of Z is equal to 1. So this is ID map on R restricted to S1 is equal to ID map on S1. So this is the definition of retraction, and this is one example of retraction map. Thank you. Allah Hafiz.